let's see, this is chapter 6, Electrochemistry. So at the beginning, we want to understand redox processes. Okay, so to understand redox processes, we start with oxidation numbers. So you see the first point that said the oxidation numbers, also known as oxidation state, is a number given to each atom or ions in a compound to keep track of how many electrons they have. Okay, so for example, a simple one, let's say I have calcium oxide. So we need to have some basic understanding on the ions here. So where we have to know that this is calcium 2 plus, this is oxide, which is O2 minus. So if you know the ions that form this ionic compound, then we will know that the oxidation number is positive 2 and the oxidation number of this is minus 2. So you can see the way that we write charge is 2 plus. The way that we write oxidation number is positive 2. So it's the other way around compared to this. And likewise here, 2 minus and minus 2. Okay, so yeah. Then next one, in a single ion or molecular ions, the oxidation number tells us how many electrons have been lost or gained. Okay, so let's say for example, molecular ion. Let's say I give one example here, carbonate, CO3, 2 minus. CO3 2 minus, you can see the charge here is 2 minus. So the 2 minus means there is a gain of 2 electrons. So gain 2 electrons. So if let's say I want to find out the oxidation number of each element, then you have to know that this oxide is O2 minus. And then this one, maybe not sure, so we don't know. Okay, let's say we don't know about that. Okay, so for the oxidation number itself, we put it in this way. So if you don't know the oxidation number, you can just put an unknown for it. So it is X, let's say, and for this we have minus 2, and we have 3 oxides there, so we have to times 3 because there are 3 oxides. 1 oxide contribute negative 2, 3 oxides, 3 times negative 2. So you add up the oxidation number here, and it must equal to the overall charge of the whole molecular ion, which is this charge, 2 minus. But we don't write 2 minus, we write minus 2. Okay, we write minus 2. So after that, you can just work it out and count to find out the x. So we just solve this equation and you will get positive 4. That is the oxidation number of carbon, where you initially don't know, then you can count it out at the end. Okay, so let's see more information. Positive oxidation number. So if you have a positive charge, that means there is a loss of electrons. If you have a negative oxidation number, that is a gain of electrons. So for example, this one, calcium 2 plus, loss of 2 electrons. Oxide, O2 minus, gain of 2 electrons. Okay, so let's move on. So on this page, oxidation number rules. So first of all, let's see the information here. The oxidation number refers to a single atom in a compound. So you must refer to single atom. A single atom. That means, for example, if you have just now the example, CO3, 2 minus. So when we talk about the oxidation number of oxygen, we must refer to one oxygen. one oxygen, the oxidation number is -2. Okay, so it refers to single atom. Now let's see the next one. The rule here. The first point, they said the oxidation number of any uncombined element is 0. So uncombined element means they don't form compound. They don't form compound. They are just one types of element. So they are 0. So oxidation number of hydrogen 0, oxidation number of zinc 0, oxidation of oxygen 0. Okay, so if they are elements form. And next one, number 2, many atoms or ions have fixed oxidation number in compounds. So for example, group 1, positive 1, group 2, positive 2, fluorine, negative 1. Okay, so hydrogens, normally positive 1, except for in metal hydride, like sodium hydride, where it is negative 1. So normally in what situation hydrogens will take negative 1? It is when hydrogen stick with group 1 metal. When they stick with group 1 metal, then they will become negative 1. So for example, like sodium hydride or potassium hydride and so on. Okay, so then oxygen is normally negative 2, except in peroxides. Peroxides, one of the famous example of peroxide is hydrogen peroxide, H2O2, where this is negative 1. The oxidation number is negative 1. Peroxide. So the other example is F2O. F2O, this is where, because fluorine is more electronegative, end up with oxygens have to be positive here. So positive. So this is positive 2. Oxygen is positive 2. This is a special case. Special case. So we have two special cases here. Peroxide is one, and this F2O is the second one. So where oxygens take an oxidation number that is inordinately, which is positive 2. Okay, so other than this, you just take it as negative 2 will be just fine. Then let's move on. Number 3. So number 3 is where the oxidation number of an element in a monoatomic ion is always the same as the charge. So this is monoatomic ions. One atom. Zinc 2 plus, positive 2. Fe3 plus, positive 3. Chloride Cl minus, minus 1. So it is direct. Okay, so then we look at number 4. The sum of the oxidation number in a compound is 0. Okay, so let's see what's that. NaCl. This is a compound. So the sum of the oxidation number is 0 because you see there is no charge. NaCl has no overall charge. Okay, so overall is 0. But if you consider individual, let's say you consider sodium alone, then you will realize sodium is positive 1, chlorine is negative 1, but if you add up, then you end up with 0. Okay, so these are some basic rules. Now let's move on. Number 5. The sum of oxidation number in an ion is equal to the charge on the ions. So let's say, for example, this ion, sulfate, the charge is 2 minus, then the sum of oxidation number is equal to -2 because of this. Because of this, the sum is -2. So we can work it out in this way, where it is kind of normal. We do it like this. SO4 2 minus. We don't know sulfur because sulfur can have all kind of oxidation number. So normally we call it X. Oxygen, we know it is 2 minus, then the oxidation number is -2. The overall is -2 because of this. Then we can just count the X and we get +6. Okay, so then we get the oxidation number of sulfur, which is +6. Then oxygen atom is -2. 4 of them end up with -8. So 6 minus 8 get -2. So calculation part, we have to practice all this afterwards. Now let's move on first. Number 6, in either a compound or an ion, the more electronegative element is given the oxidation number. Oops, something weird here. The more electronegative element is given the negative oxidation number. It's given the negative. So the less electronegative you will become positive then. So for example, this is the one. F and O, right? The more electronegative element is fluorine. So fluorine will get -1. Get -1. Fluorine, they form fluoride, so which is -1. And 2 of the fluorine, 2 times -1. And oxygen has to be positive oxidation number, +2 then. +2. Okay, it's a special case again. Now let's move on. So this is page 2, finish. Okay, so I will put this as example. Deducing oxidation number. State the oxidation number of the both atoms in these compounds or ions. So I start from A. P2O5. Okay, so let's say we want to find out the oxidation number of phosphorus. So we don't know it, we call it X, and there are 2 of them. Oxygen we know, -2. Overall charge, no, so equal to 0. So 2x equal to 10, x equal to 5, +5. Okay, so we get the oxidation number of phosphorus as +5. Okay, so I put one more example first, and for the rest I let you try it out. SO4, 2 minus. So let's say you don't know sulfur, you call it X, and then oxygen is -2, 4 of them. Overall charge is -2. Then you will get you get sulfur as +6. So the oxidation number of sulfur is +6. Okay, now I showed 2 examples already. Now you have to try out others like C until G. So you do it one by one. So once you finish C, you tell me, we discuss C first. Okay, so I just write down the answer here. This is -2, this is +3, this is nitrogen is -3, this is +3, and this is +4. Okay, so no problem, you managed to make it. Now let's move on. Here, balancing redox reactions. Oxidation number can be used to balance chemical equations. So how to use oxidation number to balance a chemical equation? Of course, this is going to be a bit hard actually, so we will look at it in details afterwards. Let's see what else they give here. Roman numeral between brackets are used to show the oxidation number of an atom that can have multiple oxidation states. So for example, this is iron. What is special about iron is known as transition elements. transition element. So what is transition element? If you look at your periodic table, so it's something like this. So this particular part is where the transition element are located. So transition element here, they have different oxidation state. So that's why we need to put in Roman numeral to say out clearly what oxidation state are we talking about. So that's why you see something like iron 3 or maybe copper 2 ions. So we have that kind of thing. Or like this is kind of famous also, potassium manganate 7. So that means the oxidation state is positive 7. So you have to know the Roman numeral. Of course, to make sure this, 1 is like this, 2 is like this, 3 is like this, 4 is like this, 5 like this, 6 like this, 7 like this, 8 like this, 9 this one 8 9 is like this, 10 is like this. More than that, no need already lah. Okay, so these are some examples for the Roman numeral. Okay, now let's see example here. Writing overall redox reactions. So that's it. Manganate 7 ions, MnO4 minus, react with iron 2 ions in the presence of acid H plus to form Mn2 plus ions, Fe3 plus ions, and water. Write the overall redox equation for these reactions. Okay, so first we just write what they give. They give us MnO4 minus, then they give us Fe2 plus, then in the presence of acid, so they give us H plus, to form Mn2 plus Fe3 plus water H2O. Okay, so these are what they give, and we need to balance the equation. Okay, the equation is not balanced yet, so we need to balance the equation. So we need to use the oxidation number concept to balance it. Okay, so in order to do this, right? Okay, let's say I look at the oxidation number of each of these first. Okay, this is the first step. First step is to check the oxidation number. Step 1, find out the oxidation number. Okay, so let's look at it. This one, manganate 7, right? So it's positive 7. Oxygen, negative 2. Oxide, so this is positive 2. This is positive 1. This is positive 2. This is positive 3. This is positive 1 hydrogen. Oxygen is negative 2. Okay, so we write down the oxidation number first. After that, step 2, we need to look for the change in oxidation number. Okay, change in oxidation number. So we have to observe the changes. For example, you see manganese, Mn. Mn is manganese. From positive 7, it becomes positive 2. positive 2. Okay, so this is a decrease of oxidation number by -5. Okay, -5. So decrease by 5. And then the other one is the iron. Iron, you can see from positive 2, it becomes positive 3. So there is an increase by 1 unit. Okay? Increase by 1 unit. Now, what to do is you have to balance the change here. Balance the change here. So, you know, this is -5. This is positive 1. So the third step, okay, let's say the third step, I write it at the side first. The third step is to balance the change in oxidation number. So how to balance the change? For example, this is -5, this is positive 1. So we need to balance in a way so that how much the minus here, how much the decrease here is equal to how much the increase here. So they must equal, you know. Okay, so what we can do is we times 5 to this. We times 5 to this. This one decreased by 5, this one increased by 5. So I times 5 to this. Okay, so let's say I put it in green color, then I times 5 to this. Okay, then I managed to balance the change, times 5. Okay, so by doing that, by multiply 5, then we manage to balance the change. -5 balance with +5. Okay, so if you times 5 to this, you need to multiply 5 to the corresponding ions here, which is iron 2 and iron 3. So we need to times 5 to this. Okay, so I multiply 5 to this. Okay, then after that, I can just balance the rest like usual. Balance the rest like normal by using the normal way. Okay, so you see manganese, you cannot put any number in front because if you put any number in front, it is not -5 anymore. So this Mn and this Mn must be 1 here and 1 here. So we just need to balance the rest. So how we balance the rest? So let's say, for example, we look at the oxygen. Oxygen. We have 4 oxygen here. Here we have only 1. So to balance it, we put 4 here. Okay, so I put 4 first. I put 4 oxygen here. Okay, so after I balance the oxygen, now I have 4 oxygen on the left and on the right. Okay, then it creates another problem. We need to balance hydrogen. 4 times 2 is 8 hydrogen. So here we need to put 8 hydrogen to balance the hydrogen. So to balance this, I put 8. Okay, now to check whether it is balanced or not, we need to do one more thing. So far at this stage, we managed to balance the atoms. Okay, we managed to balance the atom, meaning that 1 manganese, 4 oxygen, 4 oxygen, 4 O. Okay, so 5 iron, 8 H, and then 8 H. We managed to balance the atom only. We need to double check by looking at the overall charge on both sides. Okay, so now let's take a look in this way. We look at the charge here. Okay, so we start from manganate 7. So the charge is -1. Okay, -1. Iron 2 plus. 1 iron 2 plus is 2 plus. So now there are 5 of them. So the charge is positive 10. Okay, then one hydrogen is positive 1, so there are 8 of them, so positive 8. So the total charge on the left hand side is 17. 17, it's positive 17. Okay, now we check right hand side. So we have to make sure the overall charge on the right hand side is the same also, positive 17. So manganese 2 plus, so the charge is positive 2. For iron 3 ions, so one iron 3 is positive 3, so 5 of them is positive 15. So we get positive 17 as the overall charge. So I make a conclusion here. Balance the change in oxidation number, then balance the atom, and then balance the charge. So these are basically the steps in balancing the equation by using redox, by using the change in oxidation number. Okay, so settle for this. Okay, so for practice purpose, I am going to add one question here. Okay, so questions. I'm going to give you Hi plus HNO3 become I2 plus N2O3 plus H2O. Okay, so you are going to use oxidation number. So you have to try it out to balance the equation. Oxidation number plus 1 minus 1 plus 1 plus 5 minus 2, 0 plus 3 minus 2 plus 1 minus 2. Okay, so I write down the change. Minus 1 to 0 plus 1. Nitrogen minus 2. This one I explain it in this way. You know, step 3, you have to balance the change in oxidation number, right? So you need to times 2 to this one. You times 2 to this. Then this is 2 plus, this is 2 minus, they are balanced already. So you times 2 to this, right? Then, of course, at the end, you times 2 to this. You times 2 to this, it is correct. But this one no need, because you already have 2 iodine here. I2 is 2 iodine. So it is already fine, 2 iodine here, and then 2 iodine here. So that fulfill this one. That fulfill the times 2 over here. Okay, so you already have 2. The other thing that you need to balance here is based on this one, right? You're not going to times any number because the change is the same already. So 1 nitrogen will be enough already. 1 nitrogen. But here 2 nitrogen, what should we do? We just make it to 1. We multiply with 1 over 2. We multiply with 1 over 2. So that means for nitrogen, we need 1 nitrogen on each side. For iodine, we need, because times 2 here, because of that, we need 2 iodine on each side. And that is for the step 3. So step 3, we deal with it in this way. Okay, so then I just continue. Step 4, balance the atom. Okay, so we already decide. This one has to be, this one have to be 1 nitrogen to 1 nitrogen, right? So we already determined this is 1. I put a 1 in front first. So fixed already, cannot change, must be 1. this iodine I2, we fix it also because it's 2 to 2. So this is fixed also. It is 1 also. Cannot change anymore. So we have 2, 1, 1 half. The only things to balance here is the H2O. Okay, so how to balance H2O then? Let's count the atom here. So let's see the hydrogen first. Hydrogen itself, we have 2 hydrogen plus 1 hydrogen. So we have 3 hydrogen on the left. And on the right, to get 3 hydrogen, you have 2 here. So to get 3 hydrogen, so we do 3 over 2. As we know, 3 over 2 times 2 is 3. Okay, so it's 3. Yeah. So after that, let's see the oxygen is balanced or not. So you have 3 over 2 oxygen plus half times 3, 3 over 2 oxygen again. So altogether 3 oxygen. So here also 3 oxygen. So it is balanced also. So that is how we balance it. The alternative here is sometimes we don't like to have fraction in our answers. So you can just times 2. You can just times 2. If you don't want to have fractions, then you will end up with 4Hi, 2HNO3, 2I2, then N2O3 plus 3H2O. Like that. Okay, so now let's try one more question here. I'm going to write down here. So you tried it again. Another questions. So let's say Cr2O7 2 minus plus V2 plus H plus, then they form Cr3 plus VO3 minus plus H2O. Okay, so you have to balance this equation. So you take a try first. Okay, so I just write down first. Positive 6 minus 2, positive 2, positive 1, positive 3, positive 5, negative 2, positive 1, negative 2. These are the oxidation number. Okay. Minus 3 plus 3. Already balanced. Okay. Okay. So let's see. Based on what you said put half here and put half here. Okay. So let's see whether they are balanced or not, atom by atom. So first we have 1 chromium, 1 chromium, and then we have 1 vanadium, 1 vanadium, then we have 3.5 oxygen, 3.5 oxygen, we have 1 hydrogen, 1 hydrogen. So the atoms is fine, it is balanced. Now let's check the charge. We check the total charge on the left. Okay, so we have half time 2 minus is negative 1. So the V2 plus we have plus 2. Then the hydrogen we have plus 1. So the overall charge on the left is 2. And now let's check the right hand side. Cr3 plus is plus 3, minus 1, positive 2. Okay, so it is balanced. So that means the equation has been balanced in the correct way. Okay, so and normally we will do one more steps, v times 2, to get rid of fractions. So if v times 2, right, so then we will get Cr2O7 2 minus plus 2V2 plus 2H plus 2Cr3 plus 2VO3 minus plus H2O. So this final answer here is optional. It's optional. So if you don't want to have this, it's just fine to stop here with fraction as the number here. It is fine also, but it looks better if you balance it until there is no fraction. So you have two options. Either you put your final answer in this way or your final answer in this way. Okay, so at least we have done for this part. Okay, now let's move on. Okay, so let's see here. Redox and disproportionation reactions. So first, let's see what is oxidation. So they say oxidation is the gain of oxygen. So for example, copper plus H2O become copper 2 oxides. So this is the gain of oxygen. So we can see the gain of oxygen in this way. So it's like here to here. This is the gain of oxygen. So whereas H2O, right? H2O, you can see the loss of oxygen. Okay, so yeah, oxidation happened to copper. So you know when you want to mention who is oxidized, you must mention the reactant. Don't mention the product. So we mention in this way. We said it out in this way. We said copper is oxidized. Okay, so whereas water is the other way around. Water is reduced. We will learn that later, which is reduction is the loss of oxygen. So this is where H2O is reduced. Okay, then let's move on. The next one, the second point. Oxidation is also the loss of a hydrogen. Loss of hydrogen. So you can see the example here. NH3 plus Br2 become N2 plus 6HBr. Okay, so what we can see here is the ammonia to nitrogen. This is loss of hydrogen. And Br2 to HBr, this is gain of hydrogen. Okay, so again, we can use the same idea. NH3 to N2, loss of hydrogen. So this is oxidized. So we can say ammonia is oxidized. Okay, so nitrogen has lost a hydrogen and it's oxidized. Okay, so it's not loss of a nitrogen. There are more than that. If you can see that, more than one. So we just said loss of hydrogen, loss of hydrogens, then that is oxidized. Now let's move on. The third point, oxidation is, maybe we should say this first. Bromine, Br2. You can see here at the meantime. Reduction is also the gain of a hydrogen. So this is gain of hydrogen. Gain of hydrogen. So that is that is reduction. So bromine is reduced. Okay, so now the next one. Oxidation is also the loss of electrons. Loss of electrons. So let's see example. Cu2 plus to Cu. How can this become Cu? There must be receiving 2 electrons. 2 plus, then you take 2 electron, then you have to minus 2 to the charge, then you get no charge. Okay? Plus 2 minus 2 becomes 0. So gain of electron. This is gain of electron. Mg to Mg2 plus. So it becomes positive because the electron is removing, or maybe 2 electrons are taken away. So this is loss of electrons. Okay, so loss of electron is oxidation. So that means what we can say here, magnesium is oxidized. Magnesium is oxidized. So magnesium has lost 2 electrons and is oxidized. Okay, so of course we can look at the bottom at the same time. Should be on the next page. Okay, so but we can just take it in this way straight away. Yeah, if oxidation is loss of electron, then reduction is gain of electron. Gain of electron. So this is copper 2 ion is reduced. Okay, so we always say the reactant copper 2 ion is reduced. Now there are 4 definitions for oxidation. So you can see we already have gone through 3: gain of oxygen, loss of a hydrogen, loss of electrons. And the 4th definition is oxidation causes an increase in oxidation number. So how? For example, this is positive 2 to 0. This is decrease in oxidation number. So this is 0 to positive 2. This is increase in oxidation number. Okay, so based on the definition here, it refers to magnesium again, which is oxidized. So change in oxidation number of magnesium is from 0 to positive 2. There is a change of positive 2. So thus magnesium is oxidized. Okay, so of course, in the other way around, if oxidation is increase in oxidation number, then reduction will be decrease in oxidation number. So copper 2 ion is reduced. Okay, so now let's just go through the other way around. Reduction, loss of oxygen, and then next one, reduction is gain of hydrogens. And next one, we look at next page straight away. So on this page, reduction is gain of electrons, and then reduction is decrease in oxidation number. Okay, so how to remember it? Normally, when I remember, right, I remember oxidation only. So oxidation. So first they say oxygen, gain in oxygen. Then the next one will be the other way around, loss in hydrogens. Okay, then after that, the next one is electrons. Electrons is loss in electrons. Then gain or increase in oxidation number. Okay, so normally I remember pair by pair. So these two are opposite, they are one pair. So these two are opposite to each other also. This is the second pair. So you remember oxidation alone, then reduction is just the other way around. It will help. Okay, now they also give us a way to remember. They are using acronym OIRE. So OI stands for oxidation is loss of electrons. Reduction is gain of electrons. So oil rig itself will help us to remember one aspect only in terms of electrons. Okay, so let us just move on. Now, redox reaction. Redox reactions are reactions in which oxidation and reduction take place together. So while one species is oxidizing, another is reducing in the same reaction. So for example, this one again, Cu2 plus to Cu. So we know based on oxidation number plus 2 to 0, that there is a decrease in oxidation number, as we learned just now. Yeah, decrease in oxidation number is reduction. So this is reduction. And then, okay, I write down first. This is reduction. Magnesium to magnesium 2 plus. This is oxidation number from 0 to positive 2. Increase in oxidation number. This is oxidation. So when you see a chemical equation involve oxidation and reduction, that is called redox reactions. Okay, so now example, in each of the following equation, state which reactants has been oxidized and which has been reduced. Okay, so let us look at number 1. Okay, number 1, you see Na plus Cl minus, and it become NaCl. So what we can see here is the NaCl itself. Must be careful with this. We have to know that NaCl itself, the Na still have positive 1 as the charge, the Cl still have negative 1 as the charge or the oxidation number. So this is positive 1, this is negative 1. So what we can say is there is no change. There is no change. Positive 1 to positive 1, negative 1 to negative 1. So there is no change. And I have to say that this is not a redox reaction. This is not a redox reaction. So be careful with that. So this is not a redox reaction. So although they form compound, but it doesn't mean there is no more charge there. The charge is still there. Then they are ionic compound. Ionic compound has charge. Okay. Number 2. Number 2 is obvious. Magnesium is 0, positive 2, positive 2, and 0. So we look at magnesium itself, 0 to positive 2. So magnesium, there is a gain of oxidation number. Magnesium is oxidized. Okay. And Fe2 plus, Fe2 plus from positive 2 to 0, that is a decrease in oxidation number. So we can say that Fe2 plus is reduced. Okay. Now, number 3, carbon monoxide. So you have to check the oxidation number one by one. This is positive 2, negative 2. This one, okay, I'll check the back first, minus 2. And this is positive 1 times 2. Okay, this is 0. This is, check the back first, minus 2 times 2, negative 4. This is positive 4. So we check one by one in that way. Then after that, we can determine which one is oxidized and which one is reduced. So you can see this to this, there is an increase. So we can say that you don't just say carbon, you just say the whole reactant. CO is oxidized, carbon monoxide is oxidized. Okay. Then after that, Ag2O. Ag2O, you can see positive 1 to 0. So we say that Ag2O, we must say the whole reactant is reduced. Okay, so that is how we determine which one is oxidized and which one is reduced. Okay, now on this page, we have to go through the disproportionation reactions. So disproportionation reaction is a little bit different from redox. So you see the definition here. A disproportionation reaction is a reaction in which the same species. So this word is extremely important. Same species. That means the same chemicals is both oxidized and reduced. So compared to redox reaction just now, redox reaction is one species is oxidized, another species is reduced. It's two different chemicals that are oxidized and reduced. But this one is the same chemicals that oxidize and reduce. So for example, chlorine. So you can see chlorine here, Cl2. The oxidation number is 0 because this is an element. Then they change to this one. And they count the oxidation number, they realize this is positive 1. So 0 to positive 1, that is increase in oxidation number. So it's oxidized. Okay. Then 0 to negative 1, this is decrease in oxidation number. So that is reduced. It is the same Cl2 that is oxidized and reduced. So we can call this disproportionation reactions. Okay. Must be the same species. Okay. Now let's see this example. Balancing disproportionation reactions. So we look at the question here. They say balance the disproportionation reaction which takes place when chlorine is added to hot concentrated aqueous sodium hydroxides. The products are chloride and ClO3 minus. This is chlorate 5 ions and water. Okay, so they want us to balance the disproportionation reaction. Okay. Okay, so they said we have chlorine. So chlorine will be Cl2, and after that, concentrated aqueous sodium hydroxide. So if I'm doing right, I'm not going to take the sodium because I know that if I take sodium here, if I take sodium hydroxide, then they will form sodium chloride and sodium chlorate 5. They will form the product with sodium. So since the question said the products are just the anions without the presence of sodium, the cation is not there. So for sodium hydroxide itself, it is better not to take the sodium also, so that it forms ionic equations. So what we can do here is we put hydroxide, and then they form chloride, followed by chlorate 5, followed by water, H2O. Okay. I will just write down the oxidation number for each of these. 0, -2, +1, -1, +5, -2, +1, -2. Yeah. First, this to this is increase of 5 unit. then this to this is decreased by 1 unit. So to make them balance, so we multiply 5 to the top one. Multiply with 5, then we get minus 5, and then it's balanced already. So we have positive 5, have minus 5. Okay, so what to do next is, once you multiply 5 to the decrease in the oxidation number, as in here, okay, you multiply 5 to it already, so the positive 5 and the minus 5 are now balanced. So that means the increase in oxidation number is equal to the decrease in oxidation number. Okay, so once you have done this step, right, first we need to put 5 over here. I need to put 5 over here. So as you times 5, right, so we have to put 5 over here. Yeah. But here you don't put first. I mean the Cl2. Cl2 you don't put first, because by right we're supposed to have 5Cl to 5Cl minus. We don't put first because they also have ClO3 minus. Okay, so which means Cl2 over here, they form chloride, they also form chlorate 5 ions. They form these two. Okay, so we don't put 5 first. Okay, so what we can do is, since you are not multiply any number to this, so this has to remain as 1. And have to remain as 1. This one. So let's say I write 1 here. By right, no need to write if it is 1. Okay, but I just write it just to let you know that we have considered it. Okay, we have considered. Okay, now after that, now we can figure out how many Cl2 we are using here. So we have 5 Cl and 1 Cl, altogether 6. 5 plus 1 is 6. So 6 Cl. So here you have to put 3 instead. 3 times 2 is 6. So 3 Cl. Yeah. So we balance out the Cl already. Now the next thing is, let's balance off the oxygen and the hydrogen. Okay, we have to consider that also, the oxygen and the hydrogen. Okay, so first of all, let's see, we have 3 oxygen here, 1 oxygen here. So it seems like there are 4 altogether. If I put 4 here, then the hydrogen will become 4 as well. But here only 2. So I cannot put 4. That is not going to be enough. So let's try. Let's try if cannot be 4. Okay, then let's say I already have 3. Okay, so let's say another 3. Okay, I try with 3 first. Okay, so if I have, of course I have to make sure the number of oxygen and hydrogen are same, based on the left hand side here. Must be the same. So now I have 3 times 2, 6 hydrogen, 3 times 3 oxygens, 3 oxygen plus 3 oxygen, 6 oxygen also. So we have the same amount of oxygen and hydrogen. Okay, so that will be 6 on the left hand. So of course now we have to check the charge to double confirm. Okay, so to check the charge, what we can do is Cl2, 0, the hydroxide OH minus. So we have 6 of them, so 6 times -1. So the total charge on the left is -6. And then on the right, so we have 5 Cl minus, so -1 times 5. So we write down first 5 times -1, 1 times -1, water no charge, Okay, so we get -6. So if the charge are same on both sides, then it is balanced. Okay, so that's how we make it. Let's move on. Okay, next page. So on this page, we have theory, oxidizing agent. So you can see the words here. An oxidizing agent is a substance that oxidizes another atoms or ions by causing it to lose electrons. So you see the important word here is actually this one, the important word. Oxidizes another atom or ion. So oxidizing agent is oxidizing others. And the oxidizing agent itself, you can see on the next page. An oxidizing agent itself get reduced. So they gain electrons. So you have to be careful with this. They are oxidizing others, but the oxidizing agent itself is getting reduced. So therefore, the oxidizing number of the oxidizing agent decreases. So let's see example. So they give you an equation like this. And let's say we want to see who is the oxidizing agent here. So we look at the oxidizing number for each of these. So iron 2 ions, positive 2. This one, H2O2 is hydrogen peroxide. Hydrogen peroxide is where the oxygen take negative one. The hydrogen take positive one. The oxygen take negative one. Okay, then this is positive one. Then the product Fe3 plus is positive 3. And then this one, the hydrogen is positive 1, the oxygen is negative 2. Okay, so the one that is oxidized here is this one. This is oxidized. And the oxygen is reduced. This to this. This is reduced. And hence, the one that is reduced, right, is oxidizing agent. So this is oxidizing agent. So you can see here, this is oxidizing agent as it oxidizes Fe2 plus to Fe3 plus and itself and get reduced itself from H2O2 to H2O. You see from -2 to from -1 to -2, that is reduced or reductions. So oxidizing agent. Okay, now let's move on. Reducing agent. A reducing agent is a substance that reduces another atom or ion by causing it to gain electrons. Okay, so again, the idea is reduces another atom or ion. So that means reducing agent reduces others. So others will gain electrons. But the reducing agent itself, right, get oxidized. It loses or donates electrons. Okay, so therefore the oxidizing number of the reducing agent increases. Okay, so now let's see example. You have iron 3 plus react with H2O2 become hydroxide, Fe2 plus water and O2. Okay, you can see H2O2, the oxygens from -1 to 0 to 0. Okay, so H2O2 change to O2. So that is oxidized. This to this is oxidized. And iron 3 to iron 2 is reduced. So this is a reducing agent which reduce iron 3 to iron 2. You can see here, reducing agent, as it reduces iron 3 to iron 2 and get oxidize itself from hydrogen peroxide to O2. Okay, so now let's move on. For a reaction to be recognized as a redox reaction, there must be both an oxidizing and reducing agent. So that means in a redox reaction, redox reaction is where oxidation and reduction happens at the same time. Okay, so that means there are somebody who is going to become oxidizing agent and somebody who is going to become reducing agent. So these two characters are there at the same time. Okay, so let's say example, this one. This is a redox reaction because we have reduction, then we have oxidation. Okay, so let's say I just draw arrow to show clearly. This to this is oxidation. This to this is reduction. So since you have oxidation and reduction that happens at the same time, we call this redox reaction. And who is oxidizing agent and who is reducing agent? So we already discussed this is reducing agent. So the oxidizing agent, right, is the other one. The oxidizing agent is the one that go through reduction. So this is oxidizing agent. So we have something like that. And let's move on. Some substances can act both as oxidizing and reducing agent. So the example is hydrogen peroxide. In this reaction, it is oxidizing agent. In another reaction, it is reducing agent. So hydrogen peroxide can be like that. And their nature is dependent upon what they are reacting with and the reaction's conditions. So that means hydrogen peroxide react with iron 2, then hydrogen peroxide is oxidizing agent. So it depends on the other chemicals, the other substance. So if hydrogen peroxide react with iron 3, then it acts as reducing agent. So it depends on the chemicals that present. Okay, so let's move on. Okay, now let's see this question. 4 reactions are shown in which reaction is the species in both acting as an oxidizing agent. Okay, so I let you try first. You have to check the oxidation number for the elements over there, and then you can decide later. This, okay, I just write down. This is not, and not. This is the only one. So of course the reason is Fe2 plus to Fe is reduction, and hence this is oxidizing agent. Okay, so yeah, correct. Now let's move on. Roman numerals. So the first point here, they say Roman numerals are used to show the oxidation states of transition metals, which can have more than one oxidation number. Okay, so transition metals, for example, like iron. So you can see iron, we have Fe2 plus, Fe3 plus, then we call it iron 2 ion or iron 3 ion. So the Roman numeral is the one in the bracket. So they have more than one oxidation number. So we must show which oxidation number we are talking about and we put it in Roman numeral. So for example, iron can be both positive 2 and positive 3. So Roman numerals are used to distinguish between that. So Fe2 plus in FeO can be written as iron 2 oxide. Fe3 plus in Fe2O3 can be written as iron 3 oxide. So we have to write down the Roman numeral for transitions elements or transition metals. Okay, so we have to write down. Okay, now let's move on. The last page. So here, give the full systematic names of the following compound. Okay, so let's say I just show one example first. Okay, question 1, FeCl2. So first, we know the oxidation number of Cl is -1. Then there are 2 of them. So this one, let's say I don't know. I call it X. So the overall charge, nothing. So it's equal to 0. Then I get X equal to +2. And because of that, I know this is iron 2. So I write iron 2, Roman 2, chloride. Okay, so one example. Okay, now let's see number 2. HClO4. So maybe you're wondering who has different kind of oxidation number. Actually, that is chlorine. So hydrogen is fixed, +1, unless it meets up with group 1 metal like sodium, then it will take hydride, it will take -1. Hydrogen will take -1. So other than that, hydrogen is at most of the time +1. Oxygen is at most of the time -2, unless it is peroxide like just now the H2O2. So this is not, this is just the normal one for oxygen. And this is the one that we are not sure because, just now we have done question also. The Cl can be +5, can be -1, so it can have any situation. So I call it X first. Now we add up everything, then it's equal to 0. The overall charge is 0. So 1 plus x minus 8 equal to 0, x equal to 7, +7. Okay, +7. So this is chlorine with oxidation number of +7. So how are we going to name it? You just need to know that we put Roman numeral 7 in the name. So this is actually chloric acid. But we cannot just say chloric acid. We have to say chloric 7 acid. Okay, so just focus on the Roman numeral. Okay, it's +7, then 7. So after all, asking name in exam is not so popular. Okay, so we just focus on the Roman numeral. Okay, how about number 3? What you get? Nitrogen 4 oxide is correct. Nitrogen. Okay. Magnesium 2 nitrate. Oh, okay. So just for your information, the magnesium, right? It is group 2, and group 2 metal, it is always having oxidation number of +2. So we can just call it magnesium nitrate straight away. Even nitrogen also, we are not going to care about that. So nitrogen, I mean magnesium nitrate will be just enough already. Yeah. Okay. And how about number 5? Okay. Um, if you learn some basic anions from the previous one, I mean from IGCSE, let's say, so you should know that this is called sulfate, right? Sulfate. Sulfate. Okay. So uh, oxidation number is not required for sulfate. So potassium, it is group 1. So oxidation number is also, I mean, oxidation number in Roman numeral is also not required because group 1 always positive 1. And because of that, uh, we just put potassium sulfate. So Roman numeral is not necessary here. Okay, just like that. So let's look at these questions. Number 1. The price of copper is increasing as supplies of high-grade ores start to run out. The mineral cowellite, CuS, that means copper sulfide, found in low-grade ores is a possible future source of copper. When copper is extracted from cowellite, a reaction occurs between copper 2 sulfide and nitric acid to form a dilute solution of copper 2 sulfate. Okay, so now A, balance the equation for this reaction. Okay, so what we can do here, let's take a look first. They give us CuS, HNO3, CuSO4, and O, H2O. Okay, so in order to balance this, first of all, when a chemical equation is given, so what we do is we just try to use the direct way to balance. That means we just consider how many elements on the left and right, and then we balance it straight away. So unless the question mentions specifically by using oxidation number to balance the equation, then we use the way that we learned in the note just now. Okay, so here let's say I just balance it without considering the oxidation number. That gives us 3 CuS. So logically 3 copper, so on the left, so here should be 3 copper on the right, so I will start with 3. Okay, then after that I have balanced my Cu and the S. CuS already balanced. Now let's consider others. Let's say nitrogen. So nitrogen, we have 1 nitrogen. Okay, the only place to find nitrogen is here and here, okay, which is here and here. So I have to say that this number and this number must be the same. What number is that? Don't know yet. So, but it must be the same. So we consider that later. So far, we just know they must be the same. Okay, now hydrogen. Hydrogen is from here. Okay, so hydrogen's Okay, so hydrogen, this is double. Okay, then we consider oxygen. Oxygen seems like a bit hard also. Okay, oxygen, there are too many chemicals or too many substance with oxygen, so it seems like this one we can't use the normal way to balance it. So now I'm going to consider the oxidation number, because I know that considering balance the equation directly doesn't work well here. Okay, so yeah, now let's consider the oxidation number. So which means first I'm going to check this one. Okay, I know this is going to be positive 1, this is going to be x, and this is going to be 3 times negative 2, so it's equal to 0. Then after that I count x and I get positive 5, and over here I know this is negative 2, and because of that the nitrogen in front is positive 2. Okay, so I have a change from 5 to 2. That is a decrease of 3. Decrease by 3 units. And after that, decrease by 3 units. So let's see who is oxidizing here. CuS. Sulfide. Okay. So sulfide, let's see. Sulfide is minus 2. Over here, let's count it out. This is going to be positive 2. As they say, copper 2 sulfate, copper 2 sulfide. So copper is hence positive 2 all the time. Positive 2, positive 2. Let's say this is x now, and this one is 4 times negative 2. So the x here is, overall equal to 0. So the x is hence positive 6. Okay, so we can see from negative 2 to positive 6, this is an increase by 4. Increase by 4. No, increase by negative 2 to positive 6. Increase by 8. Okay, increase by 8. Negative 2 to positive 6. Increase by 8. Okay, now we need to balance these two. Okay, we need to balance these two. So what we can do is we need to change them to the common multiple, which is 24. Okay, so 24 is the common multiple. I'm going to times 3 with this. Yeah. Yes. Oh, because there is a change in oxidation number. It is sulfate, yes, true. It is sulfate. But we need to know sulfur alone, what is the oxidation number, so that we can balance it. So that's why we do so. Okay. Sulfur, so there's a change. Of course, sulfate is something that we know long time ago. Sulfate is SO4 2 minus. SO4 2 minus. So of course, if you want to do like this also can. You don't know this. Then this one is 4 times minus 2 equal to negative 2. Then you get x equal to positive 6. So it is sulfate. Okay, it's positive 6. Yeah. So the changes is positive 8 and minus 3. So that's why I want to change them to 24. The common multiple, I times 3 to this. So I have to times 8 for this. Times 8. Multiply 8. Okay, so times 3 means times 3 here and 3 here. So I have done that. and then times 8 will help us a lot, meaning that for nitrogens, it has to be 8 and 8. Yeah. Okay, so it helped a lot, the oxidation number technique. Huh? So 8 and 8. Okay, so after that, we can balance the H2O easily. So where H2O, okay, let's see, hydrogen, let's say. Hydrogens, you can see on the left hand side, we have 8 hydrogen. So here should be 4. Should be 4 hydrogen. 4 times 2 is 8. Huh? So we managed to balance it. So this is 4. Okay, so the process is quite complicated. And if you look at the marks, 1 mark only. Okay, not easy. Yeah? So much thing to do, 1 mark. Okay, now B. Give the oxidation state of nitrogen in each of the following. Okay, so let's say I do it at the side here. HNO3. So this is positive 1. Let's say this one we don't know. I call it X. Then this is negative 2. 3 of them. So equal to 0. So I count X. I will get positive 5. So this is, the answer is positive 5. And then NO. NO, let's say I show the working here. I know the oxygen is negative 2. And let's say nitrogen, I don't know, I call it X. Overall 0. So X is positive 2. So this is positive 2. Then part C. Deduce the redox half equations for the reduction of the nitrate ion in acidified solutions to form nitrogen monoxide and water. Okay, so we have nitrate ions. So I write down first NO3 minus. In acidified solution, that means we should expect H plus. Okay, and then to form nitrogen monoxide. Nitrogen monoxide. NO. NO plus water. Water H2O. Just for your information, this NO is nitrogen monoxide. So we have nitrogen dioxide also, NO2. This is monoxide. Okay, and the other thing is plus hydrogen ion because they use acid. Acidified means H plus. H plus. Okay, so we have to add H plus on our own. And the other thing is reduction. Reduction means receive electrons. If you still remember the concept, receive electrons. So the half equation for reduction, right? The electron is present on the left hand side. If half equation for oxidations, then the electrons is on the right hand side. Okay, so for example, let's say the basic one. We have a very simple reduction half equation, like Cu2 plus 2 electrons become Cu. This is a very basic reduction reaction. You can see the electron is on the left hand side. Okay? It's reduction half equation. Okay, so now let's come back to our question here. We need to balance the equation now. Okay, so to balance the equation, let's see. We look at nitrogen. Let's say nitrogen. 1 to 1. Okay, nitrogen is okay. We just leave it like this first. And then hydrogen, H plus H2. Okay, so seems like I need 2 here. If I need 2 here. Okay, so I temporarily put 2. Okay, let's say 2. If I put 2 here, then here 1, 2, here 3. Cannot balance the oxygen. So we need to use other number. We cannot use just 2. We have to use more. Okay, let's say I use, since I have 3 on the left one, so I can create 3 easily by taking 2 oxygen plus 1 oxygen on the right, altogether 3 oxygen. So left hand side also 3 oxygen. Okay, I balance the oxygen already. Now I balance the hydrogen. So since I have 4 hydrogen here, so I have to put 4 over here as well. So 4. Okay, so 1, 1. Now I check the charge. I check the charge to find out how many electrons I need here. So now I have, obviously I have no charge on the right hand side. No charge on the right. Okay, and on the left, let's see, we have minus 1. Minus 1 plus 4 is positive 3. Positive 3 have to minus 3 to get 0, because right hand side is 0. So left hand side must get 0 as well. So minus 1 plus 4 minus 3. So have to put 3 electrons here. So that I get minus 1 plus 4 minus 3 and end up with 0. So that is how we balance it. And D. Deduce the redox half equation for the oxidation of the sulfide ion in aqueous solutions to form the sulfate ion and H plus ion. Okay, so sulfide ion. Sulfide ion is the S here. The S. So it's S2 minus. S2 minus. So if you can see the equation here, we already decide the oxidation number is negative 2. So sulfide ion is S2 minus. So I write down first. Sulfide ion in aqueous solutions. In aqueous solution to form, to form sulfate ion. Sulfate ion is something that we already know, which is SO4, 2 minus, and hydrogen ion. Hydrogen ion. Hydrogen ion. Okay. So one problem here is you can see hydrogen and oxygen on the right, but we don't have hydrogen and oxygen on the left. But it is okay because we can handle it in this way. They said sulfide ion in aqueous solution. Aqueous means water, so we can put water. Put water to balance it. And then the other thing is oxidation. Oxidation means we should have loss of electrons. Loss of electron means electron on the right. Reduction, electron on the left. Oxidation, electron on the right. So basic example is like the example that we learned maybe last time is something like this. Zinc 2 plus 2 electron. And this is oxidation. You can see electron on the right, and you can see this is increase in oxidation number. So this is where we should consider, or we should know, electron is on the right. So I add 2 electrons on the, I add electron. How many electrons we don't know yet. We have to balance it later. Okay, so now we need to balance the equation. We consider sulfur first. Sulfur on both sides. So 1 sulfur and 1 sulfur. So it seems like balance already. Now we consider oxygen. So 4 oxygen, and here we should think of 4 also. So I put 4 first. I put 4 H2O over here. And after that, I have 4 times 2, 8 hydrogens on the left. So I have to put 8 hydrogen on the right. Okay, so I put 8 over there. Then after that, we consider the charge. So on the left hand side, we can easily see that the charge is -2. Sulfide contribute to this charge. Water no contribution or on charge. And then this one, sulfide -2, hydrogen plus 8. We have to get -2, we have to get -2. So how many electrons? So I just leave it as unknown first. X electron. 1 electron is -1. So now I don't know how many electrons is required. I call it X first. So I find out X. Then I will know how many electrons is necessary here. Okay, so solve this equation. -2 plus 8 minus X equal to -2. So X is equal to plus 2 is 8. X is 8. So we need 8 electrons. Okay, so yeah, like that. We balance it already. Yeah, so this is the first question. Now let's move on. Next question. Question 2. A. In acidic conditions, hydrogen peroxide H2O2 oxidizes iodide ion to iodine. The hydrogen peroxide is reduced to water. In H2O2, oxygen has an oxidation state of -1. Construct a half equation. Again, a half equation for the reduction. So we have to put electrons on the left of hydrogen peroxide to water in acidic condition. Acidic condition means you have to put H plus. You have to put H plus. Okay, so I just highlight these two important words first. This one you have to put H plus. This one you have to put electron on the left. Okay, now let's write down the equation. Okay, so hydrogen peroxide H2O2, acidic condition H plus, reduction, put electron, okay, to water, okay, they form water, H2O. Okay, now we have to balance the equation. Okay, so we have H2O on the right. So seems like, let's say we look at oxygen first. Oxygen, there are 2 oxygen on the left. So we must have 2 for H2O, so that 2 oxygen on the right happens. And it creates 4 hydrogens. 2 times 2 is 4 hydrogen. So because of that, we need to balance. We already have 2, so I need 2 more. So I put 2 here. Now we need to balance the charge. So right hand side no charge, left hand side I have +2. So I need 2 more electrons to cancel off with the charge so that both sides have no charge at all. So I balance it. I use 2 to balance the charge. So settle for this. Then part 2. construct a half equation for the oxidation of iodide ion to iodine. So iodide is I minus oxidation. Oxidation means electron on the right. Electron on the right. So become iodine. Iodine is I2. Electron on the right. We put like this. Okay, now we need to balance it. This is a bit direct. 2 iodine on both sides. And then it creates charge of -2. So I have to put 2 here to have a charge of -2 on the right. Okay, so I get the half equation ready. Now part 3, construct an equation for the overall reactions. So overall reaction, we put it in this way. We have to look at the half equation for the reduction and half equation for the oxidation, and you have to make sure their electrons are same. So for this case, they are same. If they are not same, you have to multiply with something to make it same. For example, if this is 3, this is 2, and then you have to change them to 6 electrons. So this is 3, then you times 2 to every chemicals here, and this is 2, you times 3 to everything here. Electron must be the same. So if they are same, then you can just cut the electron away. So imagine you cut the electron away, then whatever remains is something like this. Let's say I write down like this: H2O2 plus 2H plus 2 electron become H2O, then 2 iodide become I2 plus 2 electron. Okay, so to get the overall, right, you cut this and this, right? After that, whatever you have on the left, you put on the left, and whatever you have on the right, you put on the right. Yeah. If there are same thing on both sides of the equation, then you can simplify it also. Like for example, if you have H2O on the right, you have H2O on the left, then you can simplify both sides. Okay, can cancel out. Okay, now if that is the case, then we can see the answer already, which is H2O2 plus 2H plus 2I minus H2O plus I2. So this is the, yeah. Oh yeah, 2H2O. 2H2O. Okay, 2H2O. Yes. Okay, so that is the overall equation. Now, let's look at B. For B, they say chlorine react with water as shown in the following equation. So you can see this is disproportionation because Cl2 is 0, change to -1, 0 change to +1. This is +1. Okay, so I write down first. 0 to -1, 0 to +1. This is oxidation. This is reduction. So this reaction is disproportionation reaction. Now we continue. In this reaction, chlorine acts both as an oxidizing agent and as a reducing agent. Construct a half equation for the reductions of chlorine to chloride ions. Okay, again, reductions, electrons on the left. Okay, so they say chlorine to chloride. So we put chlorine to chloride. Electron on the left. Okay, so first I balance the chlorine. I have to put 2 here. Then balance the charge, I have 2 minus on the right, so I have to put 2 electrons, so that I have 2 minus on the left. Okay, now part 2, deduce the oxidation state of chlorine in HClO. Now let's say I don't know lah, okay, I don't know, so I have to do calculation in this way. HClO, you can do it like this. Positive 1, this one don't know, X, this one negative 2. So add them up, equal to 0. Okay. Then after that, you can count the X, equal to positive 1. So the answer is positive 1. Positive 1. And then part 3, construct a half equation for the oxidation of chlorine in reaction with water to form HClO and H plus ions. Okay, so oxidation of chlorine. So chlorine is Cl2 in reaction with water, so H2O. Then let's say to form HClO and H plus ion. And you see that purposely don't tell you where you should put the electron. So you have to know that oxidation, electron on the right. Electron on the right. Okay, now we have to balance the equation. So let's say first I balance the chlorine. I have Cl2 here. So I balance the chlorine. I put 2Cl over here. Okay, now I have 2 oxygens. So I have to balance the oxygen. I put 2 here to balance the oxygen. Now I have 4 hydrogens. So I already have 2 here. So I need 2 more hydrogen. Then I look at the charge. No charge on the left. So since here I have 2 plus on the right, so I need to have 2 electrons to cancel off the charge. Okay, so yeah, balance.